Number 1. A ball is thrown into the air with 100 joules of kinetic energy, which is transformed to gravitational potential energy at the top of its trajectory. When it returns to its original level after encountering air resistance, the kinetic energy is C, less than 100 joules. At first I thought it would be 100 joules because nothing changed, but because it encounters air resistance, it loses some of the energy to air resistance, so it's going to be less than 100 joules. For number 2, a runaway railroad car with mass 30 times 10 to the 4th kilograms coasts across the level track at 2 meters per second when it collides with a spring-loaded bumper at the end of the track. If the spring constant of the bumper is 2 times 10 to the 6th, what is the maximum compression of the spring during the collision? For this, I didn't really know what formula to use, so when I figured out what formula to use, it's kinetic energy initial of the car plus the potential energy of the initial of the spring equals the kinetic energy of the car final plus the potential energy of the spring final. The potential energy of the spring is 0 because it's not originally compressed, and then the kinetic energy of the car, the final, is 0 because all the energy is used. So when I plugged in my numbers, because 1/2 mv squared is kinetic energy equals 1/2 kx squared is potential energy, to find x you do the square root of mass divided by kv squared, and I got 0.77 meters. Number 4. The amount of potential energy possessed by an elevated object is equal to the work done in lifting it. At first I thought it would be the distance it is lifted, but that wouldn't make sense because if you lifted two different masses the same height or distance, they wouldn't have the same potential energy because one is going to be bigger than the other. Work is equal to the force times the distance, so potential energy is going to be possessed by is equal to the work done in lifting it because it's the distance and the force you used. For number 6, suppose a 0.3 kilogram mass on a spring that has been compressed by 0.1 meters has elastic potential energy of 1 joule. What is the spring constant? For this, I used the right equation, but I plugged in the wrong number. So the equation you're going to use is PE elastic equals 1/2 kx squared. And K is your constant, which is what you're looking for. 1 is the potential energy, and instead of 0.3 like I did, it's 0.1 is the distance, so you get 200 as the constant. For number 7, if you lift 2 loads up 1 story, how much work do you do compared to lifting just 1 load up 1 story? Well, if you're lifting 2 loads up instead of 1 load, you're going to be doing twice as much work because you're lifting a heavier thing. Number 9. A job is done slowly and an identical job is done quickly. Both jobs require the same amount of work but different amounts of power. Power is the work divided by the time. So you're going to be doing the same amount of work but in a different time because one's done slowly and one's done quickly. You're not going to use it. You could use the same amount of energy with both jobs because you're using the same amount of work. Number 11. A frictionless inclined plane is 8 meters long and rests on a wall that is 2 meters high. How much force is needed to push a block of ice weighing 300 newtons up the plane? Well, if you're looking for force, you're going to have to do the weight times the sine of the theta. And sine of theta is going to be 8 divided by 2, which is 4. So then if you do 300 divided by 4, you're going to get 75 newtons for the force. For number 18, a small economy car, which has a low mass, and a limousine, which has a high mass, are pushed from rest across the parking lot. Equal distances with equal forces. What car receives more kinetic energy? Neither receive more kinetic energy because they have the same amount, because the work is the same towards both, and work is the force and the distance, and work equals kinetic energy. Number 20. An object that has kinetic energy must have momentum. Momentum equals mass times velocity, and kinetic energy is just mass times velocity squared. So they're pretty much the same thing, so kinetic energy needs momentum. For number 21, a rock is thrown straight up with an initial velocity of 15 meters per second. Ignore energy lost to air friction. How high will the rock rise? At first I didn't understand what equation I was supposed to use, but now I figured out I have just a simple velocity equation rearranged to find the distance. So when I plugged in my equations, the final velocity is 0, the initial is 15, 2 times the acceleration of 9.8 for gravity, and x is what we're looking for, and I got 11.5. For number 22, a woman can lift barrels a vertical distance of 1 meter or can roll them up a 2-meter long ramp to the same elevation. If she uses the ramp, the applied force required is half as much. Because the work is the same, which is the force times the distance, and the distance is twice as far, the force is going to be half as much because the work has to be the same no matter what.